Morning Algebra 2 students. I'm giving you a little feedback here on assignment number 74. I did wait to gather them up until it was actually due, so I hope I got all of your questions down here, the ones that people had asked me to go over and talk about. The first one somebody asked about was question number 3, about what are the real square roots of negative 64. Well, the thing is, for this one, is that there are no actual negative square roots of 64. If you'll remember, if you're trying to take the square root of negative 64, you would come up with something like 8i, and I is imaginary, so there are no real square roots of 54. I mean negative 64. Looking at the other one, this one right here, we have a formula for the radii, finding the radii. If the volume is 500 and 800, I took the word problem and I simplified it greatly so that you could be able to take a look at it. Really what you would need to do for this problem is plug in 500 for v. So you would take the cube root of 3 times 500 and divided by 4 pi. You could do all this work in the calculator if you want to, if you're really careful with it. You can do it in steps, or if you were going to do it all in one giant thing, you would need to make sure that when you choose your cube root function, let me turn this on. When you choose your cube root function and you go down to cube root, please be very careful where you put your parentheses on this, because we're taking the cube root of an entire numerator, another parenthesis needed there, 3 times 500, or you can do that easily enough. Most of you just put in 1500, divided by the denominator. We want to make sure we group that up, 4 pi. Close the first parenthesis and close the second parenthesis and hit enter, and you'd get that value. And then for the second one, you would also find the number and then you would subtract. So that's just a little bit. Remember, find the difference mean that you subtract. So the second one, you'd plug in the 800 and find that value and subtract. This one here, this is, we can think about taking the cube root of the numerator and the cube root of the denominator. Now 2 times 2 times 2 is 8, so this is 2. And 6 times 6 times 6, I believe, is 216. Yep, so 2/6. And so you reduce a fraction always, so we end up with 1/3 for that one. This one, the open-ended one, when you take the radical expressions, you need to have 3 radical expressions, it says, that simplify to this. Well, there's quite a few that you could do. You could put a negative in front of, for example, the square root of 4x to the 4th. You could do the same thing if you wrote the cube root of negative 8x to the 6th. So what you're doing is working backwards so that you can find expressions that will give you this as an answer. It's open-ended, so you could have lots of other correct answers for that one too. These 2 questions that somebody asked about are asking you, is this always, sometimes, or never true? This number 45 is always true, because remember we said the quick way of doing this would be taking the exponent divided by the index, so 4 divided by 2 would give you x squared, and you don't have to worry about the absolute value thing because you have a squared, so that would automatically make it positive anyway, so this one will always be true. This one might fool you into thinking that it's never true because 8 divided by 3 gives you not 2, but there are a few numbers that you could plug in and it would always work. So for example, if x were 1, 1 to the 8th is 1, the cube root of 1 is 1, so that would give you 1. So there is an example. If you plugged in 0, 0 would also work. If you plugged in -1, -1 would actually also work, because when you take -1 to the 8th power, you get +1, and cube root that, you get 1, and that equals 1 squared. So this one is sometimes true. And if it's only sometimes true, you can't use this as a hard, fast rule for simplifying. So thanks for asking your questions, and you'll be able to see this and the actual lesson video today.